So good morning, all are present here. Myself, Communication Master. Currently, I am working as an assistant professor in the Department of ECE, National Engineering College. So today I am going to teach the MOSFET concept. So generally we know that MOSFET. So MOSFET stands for Metal-Oxide-Semiconductor Field Effect Transistor. Metal-Oxide Semiconductor Field Effect Transistor. So MOSFET have the several advantages as compared to BJT and the FET. So the first advantage we can say that it is high input resistance. So it consumes the less area for the fabrication. And the less power dissipation as compared with the FET and BJT. So these we can say that advantages of MOSFET. So one more advantage. So however the MOSFET is faster than the FET. MOSFET is the faster than FET. So these we can say that advantages of MOSFET. So MOSFET stands for Metal-Oxide-Semiconductor Field Effect Transistor. So now it has the several advantages as compared with BJT and the FET. So the first advantage we can say that high input resistance. The second one is it consumes the less area for the fabrication and less power dissipation, and the MOSFET is the faster than the FET. So considering this advantage, most of the ICs are fabricated with the MOSFET. So now coming into classification of MOSFET. So MOSFETs are classified two classification. One is enhancement type MOSFET. Enhancement. And the second one is the depletion type MOSFET. So now again in this enhancement type MOSFET, it is classified as N channel and P channel. Similarly for here, the depletion type MOSFET. Again here N channel and P channel. So now here coming to difference between enhancement type and depletion type. So in enhancement type initially there is no charge existing between source to drain. By applying the proper VGS value, we are creating a channel. So then if you are applying the VGS value means the IDS, some amount of the current will be flows in the device. So in depletion type MOSFET, while fabricating the device itself, the channel is existing between source to drain by using the ion implantation technique. So that is the major difference between enhancement type MOSFET and the depletion type MOSFET. So now today I am going to explain the enhancement type N channel MOSFET. So basically this enhancement type N channel MOSFET will be operated in the three regions. One is cutoff region. Second one is the non-saturation region, third one is the saturation region. Enhancement type N channel MOSFET. So now this is the basic structure for N channel MOSFET. N channel MOSFET. So this is the p-type substrate. It is filled with majority of charge carriers is holes and the minority of charge carriers is electrons. So now these are the impurities are the N plus impurities. This is also N plus impurity. Now here, this is the oxide. So now in this oxide, here it is the polysilicon. This is the polysilicon layer. So now here this is the gate element. So now this is the source. Now this is the drive. So now this structure we will try to understand with the help of output characteristics. So basically first, this enhancement type internal MOSFET will operate in three regions. One is the cutoff region. Second one is the non-saturation region. Third one is the saturation region. So now this operation we will try to understand with the help of output characteristics. So basically this output characteristics are drawn between VDS versus IDS. VDS volts and IDS is the milliamperes. Okay, so now coming into the cutoff region. So first we will see what are the conditions for cutoff region. So in the cutoff region, so VGS value is less than VT. Okay. So VGS value is less than VT. So now here we should know about what is VT. So VT stands for threshold voltage. VT stands for threshold voltage. So basically threshold voltage means the minimum voltage is required to form the channel between source to drain. So the minimum voltage is required to form the channel between source to drain. So that is our threshold voltage. So in the cutoff region, the VGS is less than VT. That means there is no channel existing between source to drain. So obviously there is no current flows in the device and we are applying the VDS. So the value of the IDS is 0. So this is called cutoff region. So now coming into non-saturation region, here the IDS value is 0. So now coming into non-saturation region, so the VGS value is greater than VT and the VDS value is less than VGS minus VT. So that means here the channel forms between source to drain. So when we are applying the gate to source voltage, so here we are applying the positive. So the electrons are attracting here and it forms the channel. So now this is the value of VGS. Okay. So once the channel is formed, when we are applying the VDS, some IDS will be produced. So when we are applying the VDS, so the electron starts moving from source to drain like this, and the current will be produced in the opposite direction. So that amount of current, how much amount of the current is produced means the IDS value we can write like this: K into 2K into VGS minus VT VDS minus VDS square by 2. So in this region, so the linear amount of the current will flows. like this. So now you are keep on increasing the VDS value. So this device, this channel grid will become reduced, and this is touching to this point. This point is called pinch off voltage. So after entering into pinch off point, so if you are keep on increasing the VDS, the constant amount of the current flows. So that region we can call it as a non-saturation region. So in the saturation region, so after in the saturation region, the constant amount of the current flows in the device. So now this region we can call it as a non-saturation. This region we can call it as a saturation. So now in the saturation region, we can write out the IDS values 2K VGS minus VT VDS minus VDS squared by 2. So now here the VDS value must be, we should submit VGS minus VT. So let us assume this is equation number 3. So in equation number 3, we can submit the VDS value equal to VGS minus VT, and after some simplification, we will get the IDS value equal to K into VGS minus VT squared. So now these are the IDS equations produced at the saturation region. Saturation region. This is the IDS value. This is in the cutoff region. So this is the IDS value 0. On non-saturation region, the IDS value is this 2K into VGS minus VT into VDS. So here the VGS is the applied gate to source voltage, here VT is the threshold voltage, and the VDS is the applied voltage between drain to source. Here the K is the device constant. So now similarly for this graph is for that I assume that VGS is fixed to 1 volt. So same thing we can repeat, and we can observe the output characteristics by fixing the various VGS values here. So now this plot we can see here. So now this is 4. The VGS is 2 volt. This is 4. VGS is the 3 volts. VGS is the 4 volts, and VGS is 5 volts like this. So this region which we can call it as a non-saturation, and this region we can call it as a saturation, and this region we can call it as a cutoff region. So now this is the enhancement type N-channel MOSFET. Similarly, we can try to understand the enhancement type P-channel MOSFET means we have to take here and take substrate, and we have to change the polarities between VGS and the VDS. So I hope this is clear. So now coming to the diffusion type MOSFET. So while fabricating the device, the channel is existing between source to drain. So that we will discuss in the next class.